So a thing that has to be considered when making sure that our universe actually remains how it is this thing known as critical density. So you might have remembered from back in the steady state model that the density of the universe pretty much has to remain constant. That is true to an extent, but um, if our density is below this critical density here, 8.5 by 10 to the 27 kilograms per cubic meter, we wouldn't actually have a universe. So, in order for an object to continue expanding, the density must be stable. That's fine. There's not much temperature change, so Boyle's law actually somewhat applies because the temperature is constant or somewhat constant. If we were trying to blow up a balloon in outer space, we would fail because the air pressure surrounding the balloon and the pump isn't sufficient, mostly because using your mouth in space isn't great. So the same can be said for our universe. So the density is this. You'd have to consider the fact that obviously because it looks very low, we might think, well, we're completely safe. But remember, this is a balance between completely empty space, which has a density of, practically zero, but this also balances out with sort of neutron stars and other dense things, like the things we discussed, magnetars, black holes, quasars, etc. So that's one thing to keep in mind, just, in case you're monitoring the density of the universe. If it goes below that, well, then we're completely screwed.